right, good morning. For those who don't know, I'm Nathan Alwad. This was the first presentation I ever gave as the asphalt engineer, so this is about the sixth time I've given it. So I'm hoping I got better at it. But so the point of this presentation, so you just looked at ITM 803 about the QCP, talking about all the equipment and stuff like that. And this is kind of some of the same information, but from the specification viewpoint, from the INDOT spec book. So to begin with, there's three main sections related to HMA. It's the 401 section, the 402. So 401 is QCQA. That's all where we take the samples and test them. 402 is your lower quantity where it's accepted by certification. And 410 is your stone matrix asphalt. Now the 401 section does contain two different types of HMA, dense graded and an open graded, which has become less used as of late, but it is still around. And then SMA is usually used on the interstate. It's more rock on rock contact, so it's a little more durable. So we'll go over those. We'll actually go over some of those QA, how those are accepted later on after lunch. But those are the three main mixes we deal with. So the specs, section 409 of the specifications kind of list all the requirements for the equipment that's actually used on the job. So this kind of tells you what is going in that QCP. Believe it or not, I mean, this is how specs are written. We actually have to say dumb stuff, otherwise it won't get done. So where we start is, hey, the plant needs to be certified. It needs to come from a certified plant. And the requirements for that are in ITM, Indiana Test Method 583. So that's our program to certify those plants. You heard it just mentioned about ICAT. That's where you get that level 1 certified asphalt technician training. It talks about how you're supposed to sample and test it in accordance with the quality control plan. You're putting where the location of your plant is, how you're going to do your daily diary, and all that kind of stuff. I just counted this. I think it was yesterday is when I counted it. There's right now about 97 plants on the that are considered certified. I want to say there's probably about 5 others that are currently inactive. They're on the list, but they don't. Some of them are missing major plant parts, so we designate them as inactive. So this is an example of ITM 583. This is just 2 pages out of the apparently 18-page document. So like on the right there, that's kind of some of the requirements. Like we say, hey, you need to talk about this in the now this is the plant quality control plan, not the paving quality control plan. Talking about what you're going to do with your aggregates, how you're going to control your recycled materials, stuff like that. Truck samples and plate samples. So that's where a lot of this stuff comes from. So we're going to move on. You got the plant. You got the certified plant now. So now we're going to go on to the equipment you use to actually lay down some of the mix. So first and foremost is the distributor, which is typically used with your tack coat. Like I said, you have to say it in the spec. It seems kind of silly sometimes, but just saying it, the distributor shall be equipped, maintained. You got to say silly things like it's got to be clean. Otherwise, there's nothing to fall back on. So, yeah, I guess this is an outline of what we're going to go through. The 4 things we're going to talk about here under Section 409. But like I said, the first part is distributor. The department's been putting a lot of emphasis on tack coat as of late, and one of those reasons is it's a very low cost material that can provide a lot of benefit for the roadway. And a lot of that has to do with the maintenance of the distributor. So we require it, again, we say the simple things, uniform heating, uniform application rates. It's got to be able to measure what's coming out of it, a thermometer on it, stuff like that. So besides tack coat, there are other applications in the spec. We don't see a lot of these anymore. Base seal, prime coat, we don't see a lot of those anymore. But again, it's used for tack coat, seal coat, and fog seal. I think that's typically done by maintenance forces, so I'm not sure there's a lot of those in contracts. But we do also use it for the joint seal, which I know there's differing opinions on that, but INDOT does require the joint seal over the joint. So tack coat. Basically, any surface you're paving on with HMA has to have tack coat on it. You know, when I first started, that picture on the left there, I mean, how many guys think that's pretty good? Anybody? I mean, sometimes that's what you see. We call that cornrows or streaking. It's not the best. It's better than some I've seen. The one on the right, that's actually a new surface. I think that was intermediate. They tacked it, let it go for a couple hours and set and break. But you can see even when some of the equipment went over it, it was taking it up. So it takes a little bit of effort to keep that tack coat on the road to bond to that next layer. We did, I wanted to say recently, I think it's going on 3 years now. I don't know, time flies. But the tack coat section actually has been updated fairly recently. We cleaned up some of the materials. There used to be 2 or 3 other materials in there, but currently we allow SS1H or AENT. Believe it or not, some of this language was not in there. Some of the simple stuff wasn't in there. Didn't really have a lot of guidance for people in the field. But we did put the language in there about the surface should not have standing water. I think there were some theories out there that the surface should be completely dry, bone dry. But sometimes that a little bit of water can actually help cut through the dust. So that's why it's worded not have standing water. Again, this language wasn't in there before. The asphalt material shall be uniformly applied across the entire width. We say cover 95% of the surface, and that you have to let it set and break. Set and break, you know, there's 2 different things. Break is when it kind of changes color. Setting is when it becomes, the tracking ability is a little less. And then we did update the application rates depending on what surface it's going on, and put a note about not allowing dilution, which, believe it or not, was a point of confusion in the past. So there you go, tack coat. Basically want to see cleaner surface, no standing water, make it some good coverage, and try to minimize that tracking. And this is what we're trying to avoid. Believe it or not, that is a state road. We think the underlying cause was the tack coat. Some other factors can play into slippage like that, but the tack coat can really help to avoid that. And then one other detour under the distributor, one other topic is the joint seal that came along, man, is it going on 10 years now? But we do require joint seal on top of that joint as well to help keep the water out. And then along with that, the joint adhesive in between the cold joint and the new lift, or the adjacent lift. And all that is really just to keep water out of the joint. One thing that is fairly new with the joint seal is we added rapid penetrating emulsion to one of the available materials. It is a different application rate, but it actually penetrates a little more It's got a reduced cure time, because a lot of time you're trying to get those pavement markings on at the end of the year. So there is some advantage there. And it has better pavement marking compatibility. It doesn't, sometimes when you put the other materials on that joint, it's harder for the pavement markings to stick. So FYI, that is now a material option for your joint seal. And then I think this is the last thing I have on joints. Just a reminder on joint compaction. Oops, sorry. Sometimes seeing that crushed rock right on that joint line is actually a good thing. It means you had enough material in that joint. The previous convention was have a pretty joint, make it nice and smooth, or you can't even tell the joint was there. And when you do that, sometimes what you end up is that thing on the right. So actually getting a good amount of material in there and crushing a little bit on that overlap means you really got the material in that joint. All right, so we talked about the distributor. Now we're moving on to hauling equipment. Again, simple stuff. Tight, clean, smooth beds, coated with anti-adhesive. We do require a cover on the hauling equipment. There is a qualified product list for the anti-adhesive material. And Jason Galetka is actually the one that maintains that. We say if there's excess material, you got to raise the truck bed, stuff like that. And then most of the plants now have automatic sprayers. Or at least some do, I would say. So I put a couple slides in here about material transfer vehicles. Believe it or not, the INDOT specs are completely silent. They don't ever mention material transfer vehicles. It was kind of one of those things, they just started being used on their own because there's such benefit for minimizing segregation and helping keep that temperature in the mix, stuff like that. So I put it in here because it is part of the laydown process, but the specs are silent. And there's some of the benefits of it. Probably needs to go without saying, but eliminates bumping. You can sometimes take out one truck out of the rotation. And like was said before, you got to just be careful at those bridge crossings. All right, we talked about distributors, we talked about hauling equipment, now the laydown equipment. And again, Brad talked about some of this in the paving QCP. But the specs do require, have some specifics on the laydown equipment. So it talks about the paver, some general requirements that are needed, self-propelled, it's got to be able to receive the material, heated and vibrating screeds that hopefully are on, auger extensions, automatic grade and slope controls. So that, again, the specs are why it requires what goes into that the paving QCP. That's why we're going over this stuff. So now we do have some specific requirements for documenting what paver you're using. And I think that stemmed from some certain makes and models, like these are specific ones in the spec. There was some known issues with those kinds, those pavers, so that there's some specific requirements in there for them, but don't necessarily need to go over those. The spec does talk about not using fuel, oil, kerosene, solvents on the paver. If you're going to use diesel or whatever to clean your tools, let's not do that on the pavement. As you can see, that's a very recent picture of a paver, right? And like I said, the spec also requires safety edge on intermediate and surface mixtures that are next to an aggregate shoulder. That just helps if somebody goes off the road, they can get back on. And there's actually 4 specific devices listed in the spec for that are available. All right, so when you can't use a paver, you got to use a widener. So wideners are usually used on shoulders where it's less than 8 foot wide. Again, there's some specifics in the spec on what that machine is supposed to be capable of doing. So kind of in the middle of this presentation, I want to take a quick detour on mixture segregation because we're at the paver, we're at the laydown spot, and this is what we're trying to avoid because those plate samples that are taken here represent a lot of money. So it's important to try to avoid that segregation as much as we can. You know, it can cause issues down the road with raveling, spalling. I know it doesn't really have to do with in the field, but it does start at the plant, getting the proper stuff in the cold feed bins, basically making sure that mix is proportioned correctly. There's stuff we can do at the plant, making sure the surge bins don't get too low. If you're constantly emptying out that silo, you can cause segregation. And the infamous tri-dump method, that can really avoid segregation as well. Front, back, middle, whatever order you want to do. Amazingly, when I go on plant audits, a lot of times trucks aren't doing it, and it's always non-INDOT mix. I can't explain it, but that's what they always tell me. That was a joke. So we try to avoid segregation at the plant. We get it in the truck. Try not to segregate it in the truck. You can help also avoid segregation by flooding that paver hopper. I've seen some different things in the field, trying to avoid segregation, not letting it build up in the corners of that paver hopper. Again, on the right there, using a material transfer vehicle with a kind of a box over that conveyor belt in there. You know, keeping enough material in that hopper, not constantly letting it run out. Keeping a constant head of material on the screed. And I know a lot of you guys probably heard this before, but sometimes you got to say the basics again. But keeping that material constant can also help with a consistent mat. And like I said, it all comes down to these plate samples, which I'll talk about a little bit more after lunch. But for, let's say, a mile of pavement, these plate samples represent that entire mile. They can represent a lot of money. And again, there's a lot of coordination between the plants and the trucks and the paving crew, all coming down to this plate sample that we take back, and the cores as well. And we threw this slide in here a couple years ago because we added on that A3 plate. I know that was confusing at first to a lot of people, but I think it's been around long enough that we're all used to it. But that we get plate samples for max, for binder, for doing our pills, and then the A3 is used for aggregate GSB testing. So we've talked about hauling equipment, laydown equipment. We also have requirements for the compaction equipment. All these are in the spec. Tandem rollers, 3 wheels, pneumatic, vibratory, oscillatory. I don't know if I've ever seen a trench roller when I'm out in the field, but I'm sure they're still used. And then there's other specialty rollers that are described. Here's for those who haven't seen it before, there is a typical paving train, or roller train, I should say. How many actually use the pneumatic tire roller in HMA paving? Anybody here? I know it's more popular in other states. think right now the only time I've seen the pneumatic tire, it's required on full depth reclamation jobs, I believe. That's usually when you see it out there. But sometimes those can help. I think they've been brought out. There's some jobs, you know, I get requests every once in a while, hey, this road sucks. We can't get density. Can you guys waive density? And a lot of times what we'll say is, hey, why don't you get some other equipment out there, try a few different things, see what we get out there. You know, as an agency, we don't really like to just waive density. We kind of want to see what we can get out there. Here's a very recent picture of a tandem roller on the left. That guy's probably not even with us anymore. But there's a more recent picture on the right. Minimum weight 10 tons, max speed 3 miles an hour. Three-wheeled roller. I don't know if I've actually seen one of these out in my travels. Anybody got one? Anybody using one? Got one up here, back there. Like I said, the pneumatic tire roller, those they kind of work a little different. They kind of knead the pavement in between those tires. The tires move up and down. They do have there's some requirements with the tire pressure. You got to watch out. You got to make sure those tires are hot, otherwise the pavement will stick to that and you'll have some issues. But again, that's another tool in the toolbox. Vibratory rollers. This was out on US 40 in Richmond, I think. We have a minimum requirement greater than 2,000 vibrations per minute. Things like that. Here's a picture of what we're talking about. We're trying to make sure that drum is actually hitting that pavement about every inch. Oscillatory rollers are sometimes used when there's some underground equipment or you're in an urban area around buildings and stuff. It can help to avoid a lot of that. It works a little differently. Doesn't impact those utilities as much. All right, so we've gone through the whole 409 section, which is all about the equipment, and then scattered throughout the spec, there's also some temperature requirements related to placement and compaction. Now, so the 401 mix, which is quality controlled, call it QCQA, we really don't have any temperature restrictions because if you pave it when it's too cold, it's probably going to segregate, it's probably going to have crappy density, which means it's going to affect your pay. So we assume that you're not going to pave when it's too cold out. But when it's a very thin lift, we do require it to be 45 degrees and rising. 402, because that is accepted by certification, we do have some more stringent requirements on minimum pavement temperatures. So for your thin lifts, thinner lifts, 60 degrees, less than 2 inches, 45 degrees and rising, things like that. SMA does have 45 degrees and rising requirement. It's probably just because we're paying a lot of money for SMA. It's usually on the interstate, so it's probably just a little margin of safety in there. And all of these, if you notice that, they all say that the subgrade can't be frozen, which is kind of a given. And just to clarify, the spec does say that when it's talking about these temperatures, that's ambient temperature and the temperature of the surface you're paving on. So keep that in mind. One newer temperature requirement relating to the mix is, believe it or not, the specs didn't have any minimum temperature requirement for the mix. Essentially, if it's not controlled by cores, if we're not taking cores to measure density, we say that the mixture behind the paver has to be 245 degrees or rising. So right there behind the screed, it's got to be 245 or rising. Now, if cores are being taken and we are paying on density, that's not necessarily a requirement, but because we assume that you don't want your pay affected, so that's why it's worded that way. And then also, so before in the previous slide, I said it's got to be it can't be frozen. What you're paving on can't be frozen, and it's got to be typically 45 degrees or rising. We also put a max on there. We're saying, hey, if you paved intermediate, you got to let that cool down before you can get onto it and pave that next course. So we put 175 degrees in there just to avoid deforming the mat, things like that. And then there are some miscellaneous things about the surface you're paving on. It's scattered through the specs. It's obvious stuff again, but you got to say it or it won't happen. The subgrade free from ruts and corrugations. There's some various things about milling. Like I said, everything's got to be tack coated. Free from objectionable materials. Top left there, that was off the internet. Actually, I think all these are off the internet. None of these are my pictures, but you know, I think there's a famous picture. I want to say I saw a shovel once paved over. I don't know. You know, don't just cover it and bury it. It's going to cause issues. I remember one job. There was a paint can just sitting there in the way, and I didn't, you know, I was just going to see how long it stayed there, and eventually somebody did come along and move the paint can right before it was about to get paved over. But anyway, all right. And then some other things again that are scattered, placed on an approved surface. We'll talk about. Later in the day, what your mixture adjustment factor is, what that's doing. If your lift was greater than 2 inches, it needs to be matched same day for safety reasons. Like I said, pavers are required when you have 8 foot or more. Basically, you want to use the paver when you can to help with a consistent mat. And then your lay rate is controlled by your max particle size. So the spec says 2 times to 5 times your max particle size. So I always forget to throw in a slide here. I got a little graph that kind of shows for a different mix size how thin and thick you can go. I forget, 9.5 I think you can do down to, is that 1 inch? I think. 1 1/4, and then I think you can go up to like 3.5 inches, something like that. 3. It might even be 4. I can't do math in front of all you guys, but so there are some restrictions there. You know, bigger, thick, 25 millimeter, you can go up to like 6 inches, things like that. And then 402 mix. Again, because that's accepted by contractor test, by certification. We do throw some other specifics in there about the mix temperature. It specifically says that the tarps need to be used when it's raining or if temperatures are lower than 45. Now, I think for the most part, I see tarps used all the time, but we do say they have to be used on 402 mix. We do slow down the paver speed. Specifically with 402 mix, and then talk about automatic slope and grade controls. Where am I going? And then this is actually in the spec book as well. We do prescribe the rolling patterns for 402 mix. I want to say option 4 is probably the most used. Just basically says 6 passes with the vibratory. There's some other options in there. So be aware that is a requirement. All right, so like I said, I've been doing this 6 years, 6 times. I think out of all those years, only one person has ever even seen this episode of Star Trek. Anybody know what this is? All right. Oh, we got one, the camera guy. All right, we got one up here too. All right, hey man, that's a record. All right. Yeah. Sorry. I guess I'm the only one who thinks that's funny, but anyway, that's all I got.